let's move on to the next speakers. We're going to hear from two people now. Susana Escudero, reporter, one of the main voices in Andalusia, because she's the person responsible for the news in the radio. She's also scientific, she has a scientific dissemination show and specializes in forensics. And now we also have Guillermo Peris, who's a chemist. He works in the field of quantum chemistry. Since we've today been talking about quantum computers, it would be very interesting. He's a partner of Reprotransportaciones, the Genome and Oncology Center in Grenada. They're going to be talking about vampires in the 19th century. Very interesting vampires, by the way. So a warm round of applause for Susana and Guillermo, please.
Buenas tardes.
Good evening. It was November 1990. 3 children were playing, going round a slide made by a pile of earth in Griswold, in Connecticut. And then suddenly they saw that 2 skulls came off from the earth. They had discovered the cemetery of the Walden family for a year. A whole team of archaeologists led by Nicholas made excavations in the area and found 29 remains or skeletons of human individuals. Apparently, this area had been used as a cemetery. So after the field work, they had to extract as much information as they could from the skeletons, right? And so they tried to make bones speak, because they say they never lie. You only have to listen to them. So the first thing you determine when you have human remains is to know the sex and age of the individuals. There were 14 adult women, 6 men, and 15 minors. 14 adult people and 15 minors. A high percentage of early death is very meaningful concerning the heart conditions in which they used to live. What can we know by studying the bones? We can know what people would do, what their occupation was, because this is also indicated by our skeleton. Researchers found that many people had injuries and marks that indicated they had carried out physical and manual work, very hard work, compatible with hard work in agriculture. But the most curious thing they found was a full skeleton of a male who was in his 50s, and on the top of his coffin it was stated JB55, probably the initials and age of the person, of the individual. And why was this skeleton so curious or funny? Because years after the death of the individual, this tomb had been opened and the bones had been placed like this as an old pirate flag. And that happened years after the individual died, because in order to place the bones this way and arrange them this way, no tissue had to be left, no flesh had to be left. There was a mystery, so anthropology started asking questions, more questions, to the bones of JB55 in order to know what had happened. And what did they see? Well, as the neighbors of this individual, he had injuries all over the place, fractures in bones. So he had been working very hard in the fields, and he had something very special about him. There was some evidence of him having a disease, because yes, bones tells us about diseases, as long as diseases are long enough as to provoke changes in the bones, which take time to react. And when does this happen? In the case of infectious diseases and chronic infectious diseases, particularly 3 ribs of GB55 had marks on them, so he had tuberculosis. Together, next to him, there were 2 tombs, IB45 and a minor, NB13, a teenager. And don't forget about them, because they're going to be important in the story. Right, how's this connected? How everything I told you about the bones of JB55 to try and answer the question we were trying to answer, which was why, years after the death of this individual, this tomb had been opened to arrange the bones in a different position. Who was JB55? So researchers had it very clear from the very beginning. JB55 was a vampire. Let me tell you why. In the region of New England had been, ever since its foundation, a cradle of superstition, and this led to many women being hanged, accused of witchdom. 100 years later, with a terrible, when a terrible pandemic of tuberculosis occurred in late 18th and early 19th century, a new hysteria occurred related to vampires in the society of New England, and this was related to the same disease. You know, death by tuberculosis was terrible. Most of people with the disease died slowly. They lost weight, they would cough blood, and they would be very thin. Their fangs could be seen very clearly. So they kind of had or looked like vampires. But this was not all. When a person died to TB, their relatives would develop the disease. At that time, they didn't know that TB was an infectious disease transmitted by contagion. So the rumor had it that people who died to TB came out of their tombs at night as vampires to suck the blood of their relatives and take them to the tomb. And there were some symptoms of the disease that led them to think that symptoms were worse at night. People would cough more, and they had this pressure on their chest as if someone had been sitting on them. And what did they do? What happened? In New England, some rituals appeared that varied from city to another, and there was this exhumation of the bodies to see if they were vampires or not. So finding liquid blood on a corpse, because fresh blood was a clear sign, the fact that the person who had died was a vampire. So if they didn't find fresh blood, but there were other signs, like for instance hair or nails growing, well, they considered that that individual was a vampire because that was not natural. In some cases, they would extract inner organs of the corpse, they would burn it, and they would give the ashes to for other people to eat them. And one of the main cases of this type of rituals was the case of Mercy Long in late 19th century in Rhode Island. This family was devastated by TB, and the first ones to die were the mother and the older daughter. But then years after, TB came back to get the remaining children. The first one who died was Mercy, the older daughter, and then the younger brother was worse every night. So rumor had it in the town that the women that had been buried in the family came back at night as vampires to suck the energy out of the child. And what do you think they did? Well, what we just told you about. They made up a group of people with neighbors and a specialized physician, and they proceeded to the exhumation of the bodies. First of all, they exhumated the bones of the women that had died years before. But when they took out Mercy's coffin that had died 2 months earlier, they saw that her hair and her nails had grown, and they found blood in her veins. So she was a vampire. So they took out her heart, her liver, they burned them, and they took the ashes, put them in water, and created a liquid that was given to her brother. This was disgusting, wasn't it? And it was useless, and the boy died 2 months later. So cases like this one were very numerous back then, and in most of the cases were private, but in many other occasions, burning hearts, like for instance in Vermont, became real public parties where many people would go, and there's evidence, bibliographic evidence about this. Only in Minnesota we have information about 80 of these cases, and back in the 90s with the discovery of JB55, we could be in the presence of the first supposed vampire in the country, whose remains people or researchers could look into. But why vampires? I mean, we've said nothing about JB55. We've never said that there were traces of people trying to access his heart. As we said, they opened the coffin at least 5 years after this person died. There was no heart, no liver at all, there were only bones. And the hypothesis of researchers is that they separated the head from the body. That was not new. This had been carried out in older cultures, like the Celts in Europe and the Egyptians in the Neolithic times. They thought that this was a good practice. And this is what happened to JB55. He was decapitated, and then they took 2 bones and put them, as you can see up on the screen. And then back in the 1990s, this spectacular facial reconstruction was carried out using the bones of his face. This is an incredible technique, and we could be talking about this for hours and hours on end. That was back in the 90s. And, well, this was JB55, right? And then 30 years later, genetics came and developed. In the 90s, when this cemetery was discovered, 2 DNA tests were taken from the bones. At the time, we didn't have the necessary tools to extract information from them. And in 2019, a team of research at the laboratory of the US Army identified the body, and for that, they used the genetic profile of Y chromosome. Why the Y chromosome? Because it's the only one that's transmitted from males to their male descendants. Right, let's recap here. We're trying to identify JB55, right? Identify. Identifying means we need to compare, make a comparison. We have his Y chromosome, but we need another reference. We need a genome to compare it with, maybe a relative, an ancestor, an offspring. We need something to compare it with. Well, yes, we are in San Sebastian, so yes, that's what we're going to do, right? We have more and more databases on human genome. They're both public and private. That belong to private companies. Maybe you've heard about some of them. You see them here up on the screen. There are companies that have a little a system to test you with a little tube. These companies have gotten data of human genomes of millions and millions of individuals all over the world. So let me tell you more about it using this family tree of the Buendías that you can find in the book Cien Años de Soledad by García Márquez. What are the main features they have in common? They're all white men, heterosexual. So they all share the same Y chromosome. Yes, but they have something more in common. Their family name. In Western patriarchal societies, sons inherit both the Y chromosome and the family name of their father. So if we have a descendant of JB55, we can compare his Y chromosome with JB55, and we will know what the surname, the family name of that individual is, right? Okay, we just need to compare it with all the men on the planet. Or do we have databases that associate the Y chromosome with the family name of the individuals? Well, indeed. In our chromosomes, we have these strands that are repetitions of short fragments that are used to identify bodies or carry out paternity tests. And here we have some groups of letters that are repeated over and over again. You see it here. You see that we have GATAG repeated 12 times. Maybe I have it 11 times and you have it 30 times. It's variable, but if we combine this variability with other positions where we see some repetitions, that is a unique fingerprint of ours, right? And this is what researchers do. They take these genetic profiles, repetitions of these names in different positions of the Y chromosome, and we have 2 columns because there were 2 samples, and that's it. Now we only have to find someone that has the same genetic profile as JB55. JB55 would be a Native American or a white European male. Well, DNA gives us that information about the origins of our ancestors. And we have companies that carry out genetic tests and tell us, well, I can tell you where your ancestors come from. So when JB55's genome was analyzed, it was found out that it belonged to a haplogroup called R1b. That's very common in Europe. So we've got all the information we need. What did the researchers do? They went to another genetic test company to carry out research. This was called Family Tree DNA, and male individuals upload their profile and give them their surname because they're looking for relatives, and this is the relationship between the chromosome Y and surname. So they carried out a research and said, okay, I want to find someone who's got this genetic profile in this haplogroup and whose surname needs to begin with letter B. And they only found 2 individuals, Barber. Well, we already have a surname, and then researchers looked in databases of old newspapers and found this. Nathan Barber, son of John Barber, died in Griswold, Connecticut in 1826 at the age of 12. Do you remember this 13-year-old boy? It could be a coincidence, and we could have already found about who was JB55. This happened 3 years ago, and researchers said, okay, we're going to keep on carrying out studies and researching to complete JB55's genome, and also his potential relatives. And that research was carried out 3 years later. It was last year. It was carried out by a company called Parabound Nanolabs, who specialized in DNA phenotyping. What is this all about? Well, it is a technique that looks at our DNA and can tell us what we look like externally, what our phenotype is, what makes us unique and different, our eye color, the color of our skin, the color of our hair, etc., etc. I think that it's broadly accepted that all that information is contained in our DNA. Look at exact twins, they share the genome and they look identical sometimes. So the problem of this technique is that these features that makes us unique and different are in different points, different areas of our genome. So the outcomes we've got are not 100% certain. There's also a probability there. And this is what they did with JB55, and this is what they found. It's almost sure that his hair color was black, his eyes were brown, his skin was light, and he had freckles. And so they made this facial reconstruction using a more advanced technique, and in this occasion they could add a lot of information that they got from the phenotype and that you don't get from bones, like the color of your eyes, your hair, etc. So this reconstruction was carried out, and well, you can compare both reconstructions. You can compare them and tell us if you think they look alike or not. In this research carried out last year, they realized that this 13-year-old boy was not the son of JB55, but his cousin. So we have new genetic tools that help us to identify individuals, and this wasn't possible until very recently, right? We don't even need anyone to compare our results with. We have many databases that are both public and public and private, and make our comparisons. The use of these databases has enabled us to detain perpetrators that were in, because there was information about their relatives there. And this leads us to an ethical debate. If you carry out one of these genetic tests, you're giving private information away. You're giving information about your relatives as well. And there's also this ethical debate going on about DNA phenotyping in order to get information about the physical appearance of individuals. According to a recent research study by New York Times, they have this powerful technology that, combined with facial recognition of all the cameras in the country, this would allow to control and find members of this ethnic group, Uyghur, that are Muslims. And in China, for instance. So we have these very powerful tools based in genetics. We cannot forget all the wonderful information that bones give us. Remember what we said earlier on. Bones talk. They talk a lot. In fact, the joint work by anthropologists and genetists leads to spectacular results, like, for instance, a reconstruction of the whole life of JB55. Thank you very much indeed.